Okay, so today we're going to finish up section P2B. Tomorrow and the next day we're going to be covering P2C. So we're still in section 2. We just split it up into several different days because it is quite a bit of information that we are reviewing. So today we're going to talk about rational exponents, in other words, fraction exponents. So here is an example and how you break it down. So when you have a raised to the m over n power, really what you're doing is turning it into a root. So when I would teach this to my Algebra 1 class, or even my Algebra 2 class, I refer to the fraction, so like here, the m over n. The n is going to be like, think about a tree. It's the root of the tree, so that'll be the root you're taking, and then the top will be the exponent. So you're going to find the root and then the exponent. Now, generally it's always easier to find the root first and then square or cube, whatever that numerator is, then apply the exponent. But sometimes you can't do that in order to simplify it. So sometimes you do have to do the exponent first and then find the root of that. Now, it's not always a square root. It's whatever number is in that denominator. So if it's a 2, it's a square root. But if it's a 3, we'll be doing a cube root. Or if it's a 4, we'll just be taking the 4th root. And we'll see as we go through these examples. So in this first one that's done for you, notice the denominator is a 2. So when that happens, this is going to be a square root. And then it's raised to the first power, and that will be the exponent. So whenever you see something raised to the 1/2 power, it's just finding the square root. Or if it's raised to the 1/3 power, we're going to be finding the cubed root. However, if you have a numerator, then after we find the cube root of the number, then we have to raise that number to whatever power is in that numerator. So this would be squared. So we'll try some examples. Pretty good? Let's try it. So the first one, it wants me to simplify. So again, remember the denominator is going to be the root, and the numerator is the exponent, or the power. So again, whenever you see something raised to the 1/2 power, think square root. So I take the 4, put it under the square root symbol, and now I'll simplify that, and I get 2. The next one, again, the 3 is the root. Now, the root is the little number that's going to go right in here. So if it doesn't have a number there, it's always a square root. So for this one, my root is going to be a 3, and my exponent is the 2. So I'm going to take the 27. I'm going to put it under the radical. I'm going to take that root number. That's going to become my index, or my little number right here. And then I'm going to raise that to the exponent. So again, you can choose here. You can either do the exponent first. I could try to do that, or I can find the root. So in this case, what I'm going to do is I'm going to find the cubed root of 27. And I know that 3 times 3 times 3 will give me 27. So the cubed root of 27 is 3. And then once I get that answer, I now do the exponent, and I get 9. Now here's where we're bringing back the day 1 of P2B, the negative exponent. So now we got a negative exponent and a fraction. So remember, the negative exponent doesn't make it negative. It turns it into a fraction. So I'm going to take, first of all, deal with that negative 1/4. I'm going to move it to the denominator. And now I can deal with the rational exponent. So that 4 in the denominator is the root. So I'm going to be finding the fourth root of 81. And then once I get that answer, it's to the first power. I really don't need to write that one. So now I have to figure out what number times itself 4 times gives me 81. And that answer is going to be 3. Because 3 times 3 is 9, times 3, 27, times 3 again is 81. The next one, again, I'm going to be finding the fourth root of 16 and then cube that answer. So I'm going to write 16, fourth root, raised to the third power. So the fourth root of 16 is going to be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. And then I will cube that answer. Final answer here is 8. Let's try the next group of examples. So again, negative power doesn't make anything negative. It makes it a fraction. So we're going to pull it underneath the 1. So 1,000. Now it's raised to the positive 2/3. And now I'll apply that rational exponent. The 3 is the root. And the 2 becomes the power. And it's still all underneath the 1. So now I need to figure out what is the cubed root of 1,000. And that will be 10. Because 10 times 10 is 100. Times 10 is 1,000. So 1 over 10 squared. And 10 squared becomes 100. Now, here we go with these negative signs, and you have to be careful when the negative sign is in front of the base, if there's parentheses around it or if it's not. So in this case, the 1/2 is only on the 100. So what I'm going to be doing here is the negative sign is going to come outside of the radical, and then I'm going to be doing the square root of 100. So it's like this negative sign drops down, and then I deal with the 100 to the 1/2 power. And again, 1/2 as an exponent really just means find the square root. So the square root of 100 is 10, and then put the negative sign in front. Now, let me just jump down to number 8, and I'll come back to number 7. Notice number 6 and 8 look the same. The only difference is there's a parentheses around the 100. So when that occurs, then what this is telling me is this power is going to go on negative 100. So it goes under the radical. Now, right now, in Algebra 1, they don't teach you about imaginary numbers. All of the things you've probably learned up to this point are only with the real number system. So whenever you see a negative number under a square root right now, you're going to tell me that this answer is no solution. Because we don't know how to find the square root of a negative number yet. We're going to learn, and we're going to end up getting an imaginary number out of it. And once we learn how to do it, it's going to become a 10i. But for now, if on the quiz on Thursday, I ask you to find the square root of a negative number, you're going to tell me no solution. So notice the difference between 6 and 8. 6 has an answer because that negative sign was not with the 100, but number 8 it is. Now we can do number 7. Now, you can find a cube root of a negative number, but you cannot find the square root of a negative number. So for number 7, Again, the 3 is the root, so I'm going to put negative 64 under the radical. I'm finding the cubed root, and then I'm going to square the answer. So here I need to figure out what number times itself 3 times gives me negative 64, and that answer is going to be negative 4. Because negative 4 times negative 4 is positive 16, times another negative 4 gives me the negative 64. So you can find the cubed root of a negative number, just not a square root. So then now that I found the cube root, now I square it, and negative 4 times negative 4, and this answer is positive 16. Let's try some more examples. So number 9, again, the denominator is the root, the numerator is the exponent. So 27, going to find the cubed root, and then I'm going to raise that answer to the 4th power. Cubed root of 27 is 3, and then I raise that to the 4th, which gives me 81. Because 3 times 3, 9, times 3, 27, times 3 again, 81. Next one, same thing. The denominator is the root. The numerator is the exponent. Square root of 64 is 8. 8 to the 3rd power, 512. Next one, we got a negative exponent and a negative number, but remember, the negative exponent turns it into a fraction. So let's first just deal with the negative 4/5. So I'm going to move this underneath the 1. I'm going to make the 4/5 positive. And now I need to find the 5th root of negative 32. It's an odd number, so I'm going to be able to do it. And then once I get that answer, I'm going to raise that answer to the 4th power. So the 5th root of 32 is going to be 2. Because 2 times 2, 4. Times 2 again is 8. Then 16. And then finally 32. So this will become negative 2. It's actually negative 2 to the 4th power. Whenever you raise a negative number to an even exponent, it's always going to turn positive. So 1/16. Now, here we go with a fraction raised to a negative power. Here's where I think reciprocal. So I'm going to first deal with that negative 3/2 exponent. I'm going to flip it. I'm going to make the power positive. And now I can find the root. So I'm going to be doing 100 over 121. And then raise to the 3rd power. Now, what we can do here is split apart the root. I can really just do the square root of 100, the square root of 121, and then after I get those answers for the square roots, I'm going to cube those answers. So I know that the square root of 100 is going to be 10. The square root of 121 is 11. And now I raise each of these to the 3rd power. So really what I'm doing here is 10 cubed over 11 cubed. And this becomes 1,000 over 1331. If you'd rather think of this as 10 times 10 like this, write it 3 times. But just remember the power will go to each piece, the numerator and the denominator. And then you'll multiply it out.
The first step, 100
Uh-huh.
So you don't. So is that? Am I making a mistake here? Did you make a mistake when you wrote 100 over 21?
So over here,
121 over 100.
so what I need to do is, the first thing I took care of was this negative exponent. And in order to change it to become a positive 3/2, I have to flip that base to its reciprocal. So that's how, so whenever I see a negative exponent, I think reciprocal. The same thing could have happened on this one. I could have put a 1 underneath this one, and then I turned it into its reciprocal, and then I started the process. So whenever you see negative exponent, think reciprocal, flip it, and then start your rational exponent process. Okay, so for the next one, we're reaching back to when we learned how to multiply exponents that have the same base. Don't worry that these are fractions, we're still adding them. So really what this means is we keep the base the same because the sixes are both bases are sixes, and we're gonna add 4/3 plus 2/3. 4/3, it already has a common denominator with the 2/3. So then I'm just gonna add the numerators. This becomes 6 over 6, which is really 1 whole. I'm sorry, 6 over 3, sorry. I don't add those denominators. Let me fix that. So this becomes 6 over 3, which becomes 6 squared. 6 divided by 3 is 2. So this answer is 36. So you just add the numerator, keep the denominator, and then 6 divided by 3 is 2. I'm going to do the same thing on the next one. It's just division now. So I'm going to take those exponents and subtract them. So really what I'm doing here is 7/3 minus 5/3, which gives me 2/3. And now I'm going to keep the bases. I do not divide 125. So this is now 125 to the 2/3 power. And again, how we just learned it, we're going to find the cubed root of 125 and then square the answer. So 125 cube root and then square. Cube root of 125 is 5, because 5 times 5 is 25, times 5 again is 125, and then I square it, and I get 25. Next one, same base. They both have a base of r. I'm multiplying, so I'm going to add those exponents. So in this case, I don't need to worry about turning the r into a positive exponent if I don't want to. I'm just going to add negative, it's really r to the negative 8/9 power plus 17/9. When I add those exponents, I get 9 over 9, which gives me r to the first, which is just r. All right, so now for this one, I've got several different options here. I could go ahead and decide, you know what, I already see that these guys have common denominators. So if you want to subtract those, you could, or you could add the denominator and then subtract. But let me go ahead and just deal with those two first. Again, different ways to deal with this. So I'm going to just first deal with these two, and it's division. So I'm going to do 3/4 minus 5/4, which is going to give me z to the negative 2/4. And because it's negative, this can also simplify first to the negative 1/2. So whenever you get a negative number when you subtract, it's going to be put in the bottom. So now what I really have is 1 over z to the 1/2 times z to the -2. And then I can add these. You know what? I think this way's too hard. Let's go back. Sorry. This is one way. Let me just finish it, and I'm going to go back and just combine it. So let me just do this first. So once I do this, I can move this to the top, and then I could get z squared over z to the 1/2. And again, I'm going to subtract 2 minus 1/2. I need to find a common denominator, so I could turn whole number 2 and make this 4 over 2 minus 1 over 2, which is 3 over 2. So final answer is z to the 3/2 power. Let's go back and try this one another way. Let's do this. Let me rewrite it. So again, always more than one way to do these. So let's do it this way instead. Let's see if this makes it easier. So these are z's. So let's instead maybe work with just the denominator, just to show you that you have options. So I'm going to need to do 5 over 4 plus, and I need to make -2.
Did Andres Dominguez get to class?
No, he did not. I'm going to turn this into a common denominator of 4, and I'm going to make it -8 over 4. So really what I did here was 5/4 plus -2, but then I turned the -2 so it has a denominator. So now I have -3/4. All right, so now what I can do is put this in here. So then now I have z to the 3/4 over z to the -3/4. And now what I can do is like a keep flip change. So I'm really doing z to the 3/4 minus 3/4. So 3/4 plus 3/4, which gives me 6/4. And then when I simplify that, 6 over 4 reduces to 3 over 2. So I get the same answer either way. So you can choose. Just know that when you're multiplying two numbers with the same base, you add their exponents, and when you divide, you subtract. So let's try another one. This one is a power to a power. And I sort of wrote in the area, so let's see. So what I need to do here is this 15 needs, it's only on the numerator. So I'm going to distribute it to here and to here. So what I'm really doing here is 1/5 times 15 over 1. So this will become x to the 3rd power. And then for the y, I'm doing 2/3 times 15 over 1. I can simplify diagonally. This becomes a 1, this becomes a 5. So 10 over 1, or just 10. So then the y gets a power of 10. And then I still have the x squared in the bottom. Now I need to simplify the x's. So I'm dividing those, so I subtract. So 3 minus 2 is 1. So I'm left with x and nothing to subtract with the y. And I leave it, and I'm done. That one was a little bit simpler. You just had to remember power to a power, you multiply. I need to do the same thing on number 18. All right, so for 18, we're going to do the same thing. We're going to raise the power to the power. So we're going to multiply 3 times 1/4. So I could take 3 times 1 over 4. This gives me 3/4. So I get p to the 3/4 power. Same thing here for the denominator, 5 over 4 times 2 over 1. I can simplify diagonally here, make this a 1, make this a 2, and I get 5/2. So now it's p to the 5 over 2 power. And now remember, once we do this, we need to subtract. Now, in this case, it would have probably been better if I didn't simplify, because now I still got to go back and find a common denominator. Does that make sense? So now that I've got this, I'm really doing p to the 3 over 4 minus 5 over 2 power. So I need to subtract 3/4 and 5/2. Common denominator will be 4. So this one stays the same. This one, I'm going to times it by 2. And then I get negative 7 over 4. So now I have p to the negative 7 over 4 power. Remember, when you have a negative exponent, it goes under a 1. So in the homework, it's going to say write all answers with positive exponents. So if after you simplify everything, if you end up with a negative power, pull it underneath a 1. And that is it for the notes on P2B. Go ahead and look for the PDF assignment. Again, remember, it's on completion right now. After this prerequisite chapter, we will start the web assign. But for now, it's just completion. Just like I did for the other homework, after 8 a.m., after the homework assignment is due, I will post the solutions. And then when you get into class, if anybody has any questions, let me know. So you can use the remaining time to work on your homework. If you get stuck on anything, let me know and I'll be glad to help you. So you have about 15 minutes where you can get started.